Hello everyone, myself Kalpana Choudhari, Department of Chemistry, RBNB College, Srirampur. We have started our topic solution, and today we are going to see the concept of osmosis and osmotic pressure from the topic solution. Now let us see first what is meant by osmosis. Now osmosis means the spontaneous flow of pure solvent through a semi-permeable membrane to a solution, or that solvent flows from lower concentrated solution to a higher concentrated solution. Now let us see, we will see an illustration of this osmosis. Consider a simple beaker in which that partition is done by a semi-permeable membrane. Partition is done by a semi-permeable membrane, and in one part of this beaker, here pure water is taken. Pure water is taken, and in another part of the same beaker, salt solution is taken. Salt solution is taken, and the semi-permeable membrane, that is denoted by a short form, that is SPM, semi-permeable membrane. Now first let us see what is meant by semi-permeable membrane. This semi-permeable membrane that allows only the solvent molecules to pass through it. It does not allow the solute particles to pass through it. That membrane is called as semi-permeable membrane. Now here we have taken this beaker, and here that partition is done by the semi-permeable membrane. In one part we have taken that pure water, and in the second part we have considered salt solution. Now here what happens, as here pure water is taken and in the another part salt solution is taken. Now here pure water that is having higher pressure, higher vapor pressure than the salt solution, because we know that in pure water, if non-volatile solute particles are added, then its vapor pressure decreases, and hence here as pure water is having higher vapor pressure, this pure water that flows through this semi-permeable membrane towards this salt solution, and here flow that continues till the concentration of this solution is become dilute. Now here what happens, as here that whatever this pure water flows through the semi-permeable membrane into this salt solution, that process is nothing but osmosis. Here what happens, we have taken here simple beaker. In one part we have taken pure water, in the another part we have taken salt solution. Now here what happens, as here water vapor pressure of water is higher, that water flows through the semi-permeable membrane into the salt solution, and here this process is called as osmosis. When pure solvent that flows through the semi-permeable membrane into the solution, that process is called as osmosis. And here if we consider another figure in the same beaker, what happens when this total water is flowed into the salt solution through this semi-permeable membrane. This is semi-permeable membrane. Here water is taken. Now here as water flows into this salt solution, the level of salt solution increases. The level of salt solution increases. This is osmosis. Now here if we can consider salt solution, if we consider here copper sulfate solution rather than salt solution, if we consider here sugar solution rather than salt or copper sulfate solution, then also the same situation is observed. That means here it is concluded that pure water that flows through the semi-permeable membrane towards the solution, or we can say that there is flow of dilute solution towards the highly concentrated solution. Because here if we consider in this beaker, for example, here if we consider dilute salt solution, and in another part if we consider concentrated salt solution, then also here what happens, this dilute solution from this, that water flows through this semi-permeable membrane towards the concentrated solution, and flow occurs till that time where that concentration of both the solution becomes equal. That means here when that solvent flows through the semi-permeable membrane towards the solution, level of that salt solution increases. Now here consider again the solution in a beaker. For example, here consider solution in a beaker, and here there is semi-permeable membrane. In one part here only pure water is taken, and here salt solution is considered. Now here initially on both the solution, atmospheric pressure is applied. On both the side, which pressure is present? Atmospheric pressure is present. Now here, as pure water that flows through this semi-permeable membrane towards this salt solution, here level of this salt solution increases, and here we want to stop the increasing level of the salt solution. Then here we have to apply the external pressure to stop the increase in level of the salt solution due to osmosis, and that pressure is nothing but osmotic pressure. That means the pressure which stops the increase in level due to the osmosis, that is called as osmotic pressure, and this osmotic pressure is denoted by the letter pi. That is osmotic pressure that stops osmosis. And here if we apply more pressure, that is pressure which is greater than osmotic pressure into this salt solution, then here what happens? Here reverse osmosis takes place. Here reverse osmosis takes place, because in salt solution also water is present. If here pressure applied is more than osmotic pressure, then here what happens? Water from salt solution that flows towards pure water, and this happens only when this pressure applied on this salt solution that is higher than osmotic pressure. Then osmosis occurs, but that is said to be reverse osmosis. That is called as reverse osmosis. Now let us see here how that osmosis is related with the concentration of the solute particles in a solution. That means here we can say that this osmotic pressure pi, that is directly proportional to the concentration of the solution, because here when osmosis takes place of that pure solvent towards the solution, if that vapor pressure difference is higher, then osmosis is also higher. That means here that osmotic pressure is directly proportional to the concentration term. Now here we can relate this pi with the number of moles of the solute particles by the equation N2 RT upon V. This is related, osmotic pressure is related with the number of moles of solute particles, where N2 upon V, that is nothing but concentration of the solution. because here number of moles upon volume in decimeter cube, that indicates the concentration of the solution, and also here N2, that is nothing but number of moles of solute particles present in the solution. That means if W2 gram of the solute having molar mass M2 is dissolved in the solution, then that N2 is nothing but W2 upon M2, that is number of moles of non-volatile solute present in the solution. That means here this equation we can write pi is equal to W2 RT upon M2 into V, and this relation gives us the relation between this osmotic pressure pi and here volume of the solution, and also that is related with the weight of the solute and molar mass of the solute. That means here we can say that all other colligative properties, that is elevation in boiling point, depression in freezing point, that properties that depends upon the concept of molality, that is concentration term, because in elevation in boiling point, depression in freezing point, there is change in temperature takes place, and whenever we are going to study the concept of osmosis and osmotic pressure, here we have to consider the concentration of the solution at a specific temperature, and hence here we can write pi is equal to M into RT, where M is the molarity of the solution. Osmotic pressure, that is related with the molarity of the solution, not with the molality of the solution, and thus here pi is equal to MRT, where that R is gas constant, and that is given by 0.082026 decimeter cube atmosphere per Kelvin per mole. T is the temperature in Kelvin, M is the molarity of the solution, and pi is the osmotic pressure. And we will stop here. Thank you.